Agoda just solved the API integration nightmare that's been haunting every AI team, and they did it without writing a single line of code.
Without code? How do you connect AI to internal APIs without building MCP servers? So we're covering how their API agent works, the schema introspection magic, and that DuckDB post-processing trick.
By minute 4, you'll know exactly how to plug any API into your AI assistant today. Let's get into it.
Welcome to the Platform Engineering Playbook Daily Podcast. Today's news and a deep dive to help you stay ahead in platform engineering.
Today we're diving into Agoda's API agent converts any API to MCP with zero code and deployments.
Stick around to the end for today's headlines. Let's dive right in.
So, Agoda just dropped something that could fundamentally change how enterprises connect AI to their internal systems. They're calling it API Agent, and here's the wild part. It promises zero code, zero deployments, and it can turn literally any API into something AI assistants can talk to.
Zero code and zero deployments? That's a pretty bold claim. We've heard promises like this before in the integration space.
Right. I get the skepticism, but here's what caught my attention. They're not trying to replace your APIs or rebuild anything. They've created this universal translator that sits between AI assistants and your existing REST or GraphQL APIs. One deployment that can handle multiple APIs simultaneously.
Wait, so you're saying I could point this at our internal inventory API, our customer service API, maybe our analytics endpoints, and suddenly ChatGPT or Claude could query all of them?
Exactly. And that's where this gets interesting for platform teams. Think about what most companies are doing right now. They're either building custom integrations for each AI tool, or they're just not doing it at all because it's too complex.
I'm seeing this at my company. We've got teams wanting to use Claude for internal queries, but nobody wants to own building and maintaining MCP servers for each service.
And that's the problem Anthropic created when they released the Model Context Protocol. MCP is great in theory. It's a standard way for AI assistants to talk to external services. But in practice, you still need developers to build an MCP server for each API, handle authentication, manage schemas, deal with rate limiting.
Plus the operational overhead. Each MCP server is another thing to deploy, monitor, patch, scale. It adds up fast.
Which brings us to what Agoda built. Their CTO, Edon Zalzberg, put it pretty bluntly. Many teams want to unlock internal tools for AI, but writing MCPs for each one is a major effort. So they took a completely different approach.
How different are we talking?
Instead of building individual MCP servers, they built one server that can pretend to be many. You configure it with a target URL and API type, and it automatically introspects the schema. For GraphQL, it pulls types and fields. For REST, it uses open API specs or learns from JSON responses.
Oh, that's clever. So it's dynamically figuring out what each API can do?
Exactly. And here's the kicker. Adding a new API is just a configuration update. No new code, no new deployment. Each API appears as a separate MCP server to the AI clients, but they're all running on the same instance.
But what about the complexity? APIs can have hundreds of endpoints, complex nested schemas, different auth methods.
That's where their architecture gets really interesting. They've built in schema search for large APIs, turn tracking for multi-step queries, and they're using DuckDB for something pretty clever that we'll get into.
DuckDB for API integration? I know, right? Unexpected. But it solves a huge problem with AI and large data sets. See, when you query an API that returns thousands of rows, that can blow right past an LLM's context window. Most solutions just truncate the data, which isn't great.
So they're using DuckDB as what, a buffer?
More than that, it's a context management layer. The full API response gets stored in DuckDB. Then they use SQL to filter and aggregate before sending just the relevant bits to the AI. And since DuckDB runs in process and handles JSON natively, there's minimal overhead.
That's actually brilliant. You get all the power of SQL for data manipulation without the complexity of a separate database.
And it aligns perfectly with how LLMs work. They're already good at generating SQL, so you can have the AI write the query to filter its own data.
But wait, what about security? If this thing can access any API,
They thought of that. Default mode is read-only. Mutations are blocked unless explicitly enabled and whitelisted. Coming up, we'll dig into exactly how they pulled this off technically and why their approach with DuckDB might be the secret sauce that makes this actually work in production environments.
all right, let's dive into how this actually works under the hood. The architecture has three main components working together: fast MCP for the server, OpenAI's Agents SDK for language model orchestration, and DuckDB for that post-processing magic we mentioned.
Walk me through what happens when I configure this for a new API. Like, I've got an internal GraphQL endpoint for our product catalog.
So you'd update the configuration with your endpoint URL and specify its GraphQL. API agent immediately hits your GraphQL introspection endpoint to pull the entire schema, every type, field, argument, the works. It builds an internal representation of what your API can do.
And for REST APIs without GraphQL's built-in introspection?
Two options. If you've got OpenAPI specs, it uses those. If not, and this is clever, it can learn from example JSON responses. You make a few sample calls, and it infers the schema from the response structure.
That sounds like it could be error-prone, though. What if the responses vary?
Their operational lessons actually address this. They found that prioritizing schema over sample data gives better results. The AI is surprisingly good at understanding partial schemas and making intelligent queries even with incomplete information.
Let's talk about this DuckDB integration. I'm still wrapping my head around using an analytics database for API middleware.
This is where it gets really clever. Let's say you query your customer API and get back 10,000 records. That's way too much for Claude or GPT-4 to handle efficiently. We're talking about context windows here, not just token costs.
Right, most LLMs start degrading performance after a few thousand tokens.
Exactly. So instead of sending all that data to the LLM, API agent stores the full response in DuckDB. Then it can use SQL to filter, aggregate, or transform the data before sending just the relevant subset to the AI.
Give me a concrete example.
Sure. User asks, what were our top 5 products by revenue last quarter? The API returns thousands of products with full details. API agent stores all of it in DuckDB, then runs a SQL query to sort by revenue, limit to 5, and maybe just select the name and revenue fields. The LLM only sees those 5 concise records.
Oh, and since LLMs are already good at generating SQL,
Exactly. The AI can write its own filtering queries. And here's the security angle. Using SQL instead of arbitrary code execution means you avoid all the sandboxing and isolation headaches. It's declarative, predictable, and safe.
What about performance? In-memory database operations for every API call?
DuckDB is ridiculously fast for this use case. We're talking microseconds for most operations. And since it's in process, there's no network overhead. They've also implemented query caching. Repeated queries get turned into parameterized recipes that skip the LLM reasoning step entirely.
That's smart. What about observability? This seems like it could be a black box.
They've integrated OpenTelemetry with support for Jaeger, Zipkin, Grafana Tempo, and Arise Phoenix. You get full traces of the API calls, SQL queries, and LLM interactions, critical for debugging when something goes wrong.
speaking of things going wrong, what happens with API errors?
Another operational lesson they learned: expose full error messages to the LLM. Turns out AI is pretty good at understanding error responses and correcting its queries. Hide the errors and it just keeps making the same mistakes.
What about authentication? Every internal API has different auth schemes.
The configuration layer handles that. You can set up API keys, OAuth tokens, basic auth, whatever your APIs need. The clever bit is that it's all managed centrally, so your AI users never see or handle credentials directly.
I'm starting to see how this could actually work at scale, but what about more complex scenarios, like querying multiple APIs in one conversation?
That's fully supported. You can query your customer API, then your orders API, and even join the data using SQL and DuckDB. It maintains context across the entire session.
That seems like it could get complex fast. How do you prevent the AI from generating expensive or problematic queries?
They've built in safeguards, query complexity limits, timeout controls, and remember, read-only by default. For mutations, you have to explicitly whitelist not just the API, but the specific operations allowed.
The more we dig into this, the more I'm seeing why they needed all these pieces. It's not just about protocol translation.
Right. It's about making AI to API integration actually practical for ops teams. No custom code means no bugs to fix. No deployments means no release cycles to manage. Stick around. We'll break down exactly what this means for your platform strategy and how to evaluate if this approach makes sense for your organization. So let's talk about what this actually means for platform teams. Because on one hand, we've got this tool that promises to solve a real problem. On the other hand, we need to think critically about where it fits.
Yeah, I'm thinking about my team. We've been putting off AI integration because of the complexity. Is this the answer, or are we just kicking the can down the road?
Great question. Let's start with where this makes absolute sense. If you're a company with dozens of internal APIs and you want to enable AI assistance quickly, this is probably your fastest path. The alternative is months of development building individual MCP servers.
Especially for read-only use cases. I'm thinking about our support team wanting to query customer data, or product managers pulling analytics.
Exactly. And here's a key insight. This isn't about replacing your APIs or rebuilding for AI. It's about making your existing infrastructure AI accessible. That's a fundamental shift in thinking.
But what about the limitations? This can't be the solution for everything.
You're right. If you need complex business logic, real-time streaming data, or heavy computational operations, you'll probably still need custom solutions. API Agent is best for CRUD operations and data queries.
What about the build versus buy decision? This is open source, but running it in production is different from experimenting.
Here's my framework. Calculate the cost of building MCP servers for your top 10 APIs. Include development, testing, deployment, and maintenance. If that's more than 3 months of engineering time, API Agent probably makes sense as at least a transitional solution.
Transitional is a good word, because long-term, do we want this abstraction layer?
That's the strategic question. Some companies will use this as a bridge while they rebuild their APIs to be AI native. Others might find this abstraction is exactly what they need permanently. It decouples their API evolution from AI tool changes.
Speaking of AI tools, we've been talking about ChatGPT and Claude, but what about future AI assistants?
That's the beauty of using MCP as the protocol. Any AI tool that supports MCP can use these integrations. You're not locked into OpenAI or Anthropic. As new AI platforms emerge, they just need to support the standard.
So what should teams do tomorrow if they want to explore this?
3 steps. First, identify your highest value read-only APIs, the ones people are constantly asking for data from. Second, grab the open source code and run a proof of concept with 1 or 2 APIs. Third, measure how long it takes versus building a custom MCP server.
What metrics should they track?
Time to first query is huge. How fast can you go from 0 to AI querying your API? Then look at query success rate, response times, and critically, how often users hit the context limit and need that DuckDB filtering.
Any red flags to watch for?
Yeah, a few. If your APIs have complex authentication flows that change frequently, this might be painful. If you need sub-second response times for all queries, the LLM overhead could be an issue. And if you're in a highly regulated industry, adding another layer of data access might complicate compliance.
What about the broader implications? Where does this trend lead?
I think we're seeing the emergence of AI-ready infrastructure as a category. Just like we went from mobile-first to cloud-native, we're heading toward AI accessible as a default requirement for internal tools.
That's a big shift. It means every API we build needs to consider AI consumption patterns.
Exactly. And tools like API Agent are the bridge to get us there. They let us experiment with AI integration without massive rewrites, learn what patterns work, and gradually evolve our architecture.
And final thoughts for platform engineers listening?
Don't wait for the perfect solution. The teams experimenting with AI integration today, even with imperfect tools, are learning what their organizations actually need from AI. That knowledge is more valuable than any specific technology.
And specific to API Agent.
It's open source. The cost of trying it is basically zero. Even if you don't use it in production, you'll learn something about your API design, your data access patterns, and what your users actually want from AI integration. That alone makes it worth a Friday afternoon experiment.
I think that's the key takeaway. This isn't just about a tool, it's about starting the journey toward AI-accessible infrastructure.
And here's the thing. In 2 years, every platform team will need to answer the question, can AI talk to our systems? The teams starting now, even with simple tools like this, will be the ones ready with a good answer. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating new development from Docker that's catching attention in the platform engineering community. They've introduced a new shell sandbox type that lets you run NanoClaw, that's a Claude-powered WhatsApp assistant, in a completely isolated environment.
Oh, this sounds like it addresses a real security concern. Are we talking about running AI assistants without worrying about them accessing sensitive data?
Exactly. The Docker blog post walks through the entire setup. And what's clever is how they're using these sandboxes to create secure execution environments for AI tools. It's particularly relevant now that everyone's integrating AI into their workflows.
This could be a game changer for teams wanting to experiment with AI assistants without compromising their security posture.
Moving on to something equally interesting, Red Hat developers have published a deep dive into performance testing identity management systems using encrypted DNS and core DNS in OpenShift clusters.
That sounds pretty niche. What's the big takeaway here?
Well, they managed to achieve optimal performance by tuning IDM and bind configurations. The article shows real-world load testing scenarios that platform teams can apply to their own identity infrastructure.
So essentially, if you're running IDM in production OpenShift environments, this gives you a blueprint for stress testing and optimization.
Now, here's something provocative. Cloud Native Now published a piece called Gastown, What Kubernetes for AI Coding Agents Actually Looks Like.
Gastown. That's an interesting title.
It's about Steve Yege's work on orchestrating multiple AI coding agents using Kubernetes. The key insight is that single-agent AI systems have limitations, but when you start treating AI agents like microservices...
Oh, so we're talking about distributed AI workloads. Each agent specializes in different tasks, and they coordinate through Kubernetes.
Exactly. It's pushing the boundaries of how we think about AI infrastructure. Instead of one monolithic AI doing everything, you have specialized agents working together.
That's a fascinating evolution, applying cloud-native patterns to AI orchestration.
That wraps up today's news. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
And check out platformengineeringplaybook.com for more resources and guides. Until next time.